equation is y equals. Okay, we know as a bullet is fired, its initial speed resolved into two components, the x-axis and the y-axis. When the x-axis remains constant, the y-axis the vertical component varies. So we can determine this by calculating vertical speeds using the equation of motion. So for this problem, break it down into its vertical and its vertical component of speed. So to do that, it's the equation is y equals v2 0, the initial sine squared of our angle theta. So hence the minimum height reached, the maximum height reached would be y max equals h plus theta over 2g. And the vertical speed of an object in free fall, v squared y equals v0y squared plus 2gy. And as a projectile falls from our highest point, its initial speed is 0 and y equals y max. So we have v squared y equals 2gy max squared equals 2g y max. So the resultant speed is given as this formula. We know a bullet was fired with an initial speed of v of 0 at an angle above the horizontal is theta. And since the vertical speed at the highest point is 0 and acceleration equals negative g, we can use the following equations from above to solve for it. So v squared y equals 2g h plus v20 sine squared theta over 2g. We square the horizontal components of speed is our cosine squared of theta. At that point then we can substitute the values of Vx and Vy in the equation, and we end up getting v squared equals v cosine squared of theta plus 2gh plus v0 theta over 2g times 2g, which then equals to v0 cosine squared theta plus 2gh plus v20 squared of theta 0 cosine squared of theta plus sine squared of theta plus 2 times gravity and height, and equals 2 v squared of initial plus 2gh. Now since this problem wanted us to supply our answer in terms, not for solving it, based on this our final equation, therefore the speed of the bullet as it strikes the ground, you would use this equation. Plus 2g of h. Now from this equation, the final speed depends upon the horizontal and the vertical components. Both terms containing theta are eliminated, so hence the speed at which the bullet strikes is independent of the angle of the projection of theta. This is Michael Diamond, and this is standard number 4.